Good evening, Honors Algebra. Mr. Lawrence here with your flipped lesson for Tuesday, March 13th. And we've got a quiz tomorrow on story problems, so I'm expecting you to know a few things. Remember, we're usually looking to factor. We look to factor often. Okay? We can factor things, we can usually solve them. Usually. When we can't, we'll need the quadratic formula, which I will mention later on. All right. We also need to know consecutive integers. Okay? If the first integer, it says like 3 consecutive integers. Well, what's the first one? We don't know, so we call it n or x or something like that. The next one would be 1 more than n, which would be n plus 1. And then the next one after that would be n plus 1. Oh, excuse me, n plus 2, right? Those would be consecutive integers. You've got to pay attention, though, if it says something like consecutive odd or consecutive even. All right, consecutive odd or even, they both work the same way. Again, you don't try to make the variable odd or even. You just say it is. So your first is n. Okay, you don't try to do anything to it. Or if it said a negative integer, you wouldn't do like negative n. You would just put n. Okay, and then if we're going consecutive odd or even, well, odd numbers go 1, 3, 5, 7, etc. They're skipping 2. Even numbers go 2, 4, 6, 8. They're skipping 2 also. So the next consecutive even number would be n plus 2. And the one after that would be n plus 4. And I'm adding 2 each time. Okay, sorry about that. I had to sneeze. Now, remember, if it's negative integer, you don't put negative n. You just use the variable. Okay. Now, if it asks you, say like on the second one, if it said to square the third of 3 consecutive even integers, square the third of 3 consecutive even integers. Well, we've got this, this, and this. There's the third one right there, right? I need to square it. That is not this. This is not correct. This is the first consecutive of even integers plus 16. And that's not what we want. We want the third one squared. We have to put it in a quantity. Now, that's a FOIL situation. Remember, that equals n squared plus 8n plus 16. It does not equal n squared plus 16, right? You have to FOIL it. Did I say you have to FOIL this? You have to FOIL that. If you need to, some of you should actually do this. N plus 4 times, oops, as a quantity times n plus 4 as a quantity. Okay? And that will get you this result. All right, so I wanted to mention that. Let me see, hold on one second. Remember that sometimes we end up with extraneous roots, things that don't make sense, and so we throw them away. Hold on one more second. Problem 36 from your packet, I'm on 7-9, solving equations by factoring, 293. Problem number 36 says the product of a certain negative number decreased by 5. Well, the certain negative number is just n. You don't make it negative n, like I've said only about 10 times now. Decreased by 5. And the same number increased by 7 is 0. All right, well, I solve these for n. I can get n equals 5 or n equals negative 7. Now, in the story, it says the product of a certain negative number. This is not a negative number. I will not present n equals 5 as an answer. I might have the work down, but for my answer, I will circle n equals negative 7. Now, we can test it. Negative 7 minus 5 and negative 7 plus 7. Is that going to equal 0? Well, look, don't waste your time even worrying about this. This is going to turn to 0, and 0 times that guy will equal 0 by the zero product property. So yes, it does work. Okay, let me see here. Let me do number 40 for you. Same page, number 40. You have the solution set of 0, 7, and negative 3. Well, work backwards. We know that n equals 0, n equals 7 or n equals -3, which implies that this is n minus 7, this is n plus 3, and this one's just a plain old n. I saw Myriad Brandis today write n plus 0 here as a quantity, and I think that was a smart thing to do. It's a baby step, but it's a very smart baby step because it's going to help her get the right answer. So I'm very proud of her for doing that. Okay, and then hopefully she simplified that and said, well, that's just n. But it was very consistent for her to do that, and I think it was a really smart idea. Now, personally, I would FOIL the quantities of n minus 7 and n plus 3 first, and then distribute. You could distribute first, but don't over-distribute. If you distribute, the n can only go to one of the quantities. Don't make it go to both. All right? But I would like to FOIL first. That's how I would do it. So I'm going to get an n squared. I'm going to get a minus 4 and a minus 7 and a plus 3 is a minus 4n, and then a minus 21. And then when I distribute, I will get n cubed minus 4n squared minus 21n. And I do need that to equal 0. I should have put that in the beginning. Okay, and there is my equation. Without the equal 0, it's not an equation, it's just an expression. So make sure you're answering the question. All right, let me see here. Okay, let's try, I'm on page 710, lesson 710, more solving equations by factoring. And problem 10 says the product of two consecutive integers. Well, the first integer is n, the next consecutive one is n plus 1. The product of them would be n times the quantity of n plus 1. All right, is 110. There we go. Distribute, I'll get n squared plus n equals 110. I want it to equal 0, n squared plus n minus 110 equals 0. And now I'm ready to factor. I need two factors of 110 that subtract to get positive 1. Well, how about 11 minus 10? I don't even need to list all the factors on that one. N plus 11 and n minus 10 equals 0. This allows me to say that n could equal negative 11 or n could equal positive 10. All right, now let me go back and check the problem. It says the product of two consecutive integers. So if n is negative 11, then n plus 1 would be negative 10. Let's check. Multiply, do I get positive 10? I sure do. Or if n is 10, then n plus 1 equals 11. So you see there are two solution sets possible. You might have negative 10 times negative 11, or positive 10 times positive 11. Both will yield the result, and the problem doesn't mention anything about the integers having to be positive or negative. All right, you've got the answer key to the problems that we did. Remember, skip 62. If sometime you're bored or something and you can figure out a more viable solution for it, I would certainly give you some credit for that, some bonus kind of credit. I'm having a lot of trouble with that problem. I keep coming up with W to be a negative answer, which is not possible. I've tried to guess and check method, which I'm not allowed to solve using factoring because it ends up with non-integer coefficients. So it's not that I'm not allowed, it's way more difficult to do that. Quadratic formula is much more suited to that, but we haven't learned that yet. Okay, by the way, I want to mention the quadratic formula. You will be singing this to me. You must get this right. You must memorize this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Got it? Make sure you memorize that. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, make sure you know that. I'm going to be quizzing you in the hall, stopping you, making you sing me the formula. You don't actually sing it, but you will have to be able to recite it. You have to memorize this formula. I don't normally make you regurgitate formulas, but instead of deriving this on your own every time, it's easier Way easier to just learn it as it is. Somebody's already derived it for us. All right, Mr. Lawrence signing off. Have a good night, everybody. Good luck on your quiz tomorrow.